All right, guys, just a short video today. Today's mostly going to be formula work. It's not going to be as abstract as the last class. You're just going to be using formulas, plugging in the numbers from the picture of the circle. Some of the numbers will be given to you. Sometimes you'll have to do a little bit of math to determine the number. So, let's talk about one of the few things from the last lesson that you'll need to know to do today's homework. So one thing I want you to remember, if I have a circle and a point in the middle, we have an arc measurement. So if I take this blue section of the circle, this is called an arc, okay? If I connect from the center of the circle to the ends of that blue arc, let's say this is 40. Nope, that's not even close to right. We better go this. If this arc is 85 degrees, this measurement right here is 85 degrees, or the other way around. If one is 85, the other one is 85. If I extend, instead of connecting these endpoints to the center, if I connect them anywhere else on the circle, I get a different angle. This angle is going to be half of the other two blue angles. So it's going to be half of whatever those other two measurements are. So be careful. Some of the pictures are going to give you this measurement here on the outside, and you'll have to determine these two measurements. It might give you a measurement on the outside. It might give you this measurement and call it 50 degrees and this measurement and call it 120 degrees and ask you to find the missing measurement. For that one, remember that all of the outside of a circle adds up to be 360 degrees. Other than that, everything you need to know, you're going to learn today. So let's review a couple formulas really quick. They're all at the top of your page. You can fast forward right to where we start doing problems if you need to. First formula, circumference. C stands for circumference. The 2 is always a 2. The pi is always a pi. You are welcome to use 3.14 instead of the pi button on any calculator. That's okay with me. And then R stands for radius, of course. Area of a circle. A stands for area. Pi is pi, or 3.14 again. Radius is the R again. And squared is squared. It's what it always is. Arc length. So last class, when we talked about these arcs, when I talked about the arc of the circle, we were using degree measurements. Today, this formula tells you how to find the actual distance of that arc. So if you were measuring it with a ruler or ribbon or anything else, what is the actual length of this arc, not what is the degree size of the arc. So they're similar, but different. In order to find the length of the arc, you are going to use pi again. You're going to times it by the radius r. And then it asks you to multiply by, it has this little symbol that represents the measurement in degrees of an angle. So you'll notice on the picture, it shows you, whoops, I accidentally highlighted the R too. It shows you where that angle comes from. And that's the one that sometimes you're gonna have to find, because it might not give you that perfect angle on the inside. It might give you this outside angle right here. Or it might give you one of the distances around the shape, and you have to use that to find that highlighted yellow angle. Area of a sector. Instead of finding the area of the entire sector, what if I just want to find how much area one slice of the circle is? So kind of what's the area of my slice of pizza or my slice of pie? That formula uses a lot of the same pieces. It has pi, it has radius, but this time it's radius squared. It has the angle measurement from right here in the center of the circle. and it has 360 degrees on the bottom instead of 180 degrees. So be really careful using this formula that you use 360 instead of 180 and that you use r squared instead of r. Otherwise, it's pretty much the same formula. Power of the point theorem. If two chords intersect each other, we've got two chords. We've got this yellow one right here, and we've got this blue one right here. And each of them are broken up into two parts because they intersect each other. Well, something unique happens. If I take this n part and I multiply it by m, I'm going to get some number, right? It is going to be the exact same number as if I take p and multiply it by q. So if I multiply those two parts together, they equal what I get when I multiply the other two parts. All right, let's do some math. Find the area and circumference of a circle if the radius is 9 centimeters squared. So we've got to look for the area and the circumference. I have a formula for both of those. The area formula, A equals pi r squared. So I need to know what my radius is. Hooray, it tells me in the problem it's 9. So the area is going to equal pi multiplied by 9 squared. Now here, I'm not super picky about your answer. 9 squared is 81. So this turns into 81 multiplied by pi. I love that answer. If you don't like 81 pi, I guess that would be a better way to write it. Let's rewrite it as 81 pi without the multiplication symbol. If you want to actually multiply that to get the decimal, I'm okay with that answer as well. So if I go to my calculator, calculator. If I do 81 multiplied by pi, my pi might be in a different place than your pi, or I can just do 3.14. Either way, I get 254.34. So my area is 254.34 or 81 pi. I'm happy with either one of those answers. Now to find the circumference, the formula up above tells me to take 2, multiply it by pi, multiply it by radius, r. So that is going to equal 2 multiplied by pi multiplied by 9. 2 times 9 is 18, so this is either 18 pi, that would be a great answer, or if you want to plug it in your calculator, you do 1/8 times 3.14, and you get 56.52. So 56.52 would also be an acceptable answer. Okay, number 2. It wants me to find the same thing, but this time it gives me the diameter. I need to be a little bit careful when I plug the diameter into these problems because I shouldn't be plugging in the diameter. I should be using the radius. So usually when a circle problem gives me the diameter, most formulas use radius. So the first thing I do when I see these problems, as soon as it says diameter is 12, next to it I write, well, that means the radius is 6. There's no reason for me to use the diameter. It's always the radius that we use in problems. So radius is 6. Now I'm going to find the area, which is pi times the radius 6 squared. 6 squared is 36. So 36 pi would be one answer that I would accept, or you can do 36 times 3.14 and get 113.04. So 113.04 is another acceptable answer. Circumference equals 2 times pi times my radius, 6. 2 times 6 is 12, so 12 times pi. I'm just going to write it 12 pi. I like that better. That's an acceptable answer. Or, once again, 12 times 3.14. I accidentally did 0.12. Don't do that. Bad things happen. Delete, please. 12 times 3.14 is 37.68. So 12 pi or 37.68 would be an acceptable answer. Number 3, find the radius of a circle if it gives you the circumference. I like this problem. I'm still going to use the circumference formula. Circumference equals 2 times pi times radius. But this time it gives me, instead of giving me radius, it gives me circumference. So I'm going to replace circumference with 50. So 50 equals 2 times pi times radius. Do a little bit of railroad track to get radius alone. Divide by 2, and that goes away. 50 divided by 2 is 25. So 25 equals pi times radius. To get rid of pi, I divide by pi. So 25 divided by 3.14. So 25, I did decimal again. 25 divided by 3.14. Enter 7.9617834. Let's just go 2 decimals the whole time. So 7.96. So radius is going to equal 7.96. Okay, number 4, find the radius if it gives you the area. All right, well, that's similar to what we just did, but with a different formula. Area equals pi times radius squared. So I replace area with 95. 95 equals pi times radius squared. Railroad track. Whoops, don't erase. Railroad track. I want to get rid of the pi first, so divide by pi. 95 divided by pi, yuck. 95 divided by 3.14 gives me 30.25. So 30.25 equals radius squared. Don't forget that it's radius squared when we're doing area. The opposite of square is square root. So I'm going to square root 30.25. Talk about ugly numbers. Second square root 30.25. And I get 5.5. Okay, not such a bad number. 5.5 I can live with. Radius equals 5.5. Ta-da. Okay, number 5. Find the arc length of AB and the area of the shaded vector. So AB is this arc right here. And it wants me to find the arc length and the arc area. Or I guess the sector area. So let's start with arc length. That formula, capital L, equals, it's right up above, pi times radius times the angle I'm using, all divided by 180 degrees. So when I look at this picture, I know the radius, it's right here, it's r, equals 9. But notice that it gives me this angle on the outside of the circle. So it's not connecting to the center of the circle. So my angle I'm going to use is not 72 degrees. I want this angle right here in the middle. Maybe I should have used a different color. I want this red angle, not the purple angle. Well, to get from the purple angle to the red angle is easy. I just times it by 2. So this red angle is 144 degrees. So now that I know my angle and my radius, I'm going to plug them in. Capital L equals pi times radius 9 times angle 144, all divided by 180. See if I can remember that. Pi 9, 144. Hit the right button. So I'm going to make a fraction because I don't want to try to do parentheses. So pi 3.14 times the radius 9 times the angle 144. And then on the bottom, I'm going to divide by 180. Be careful putting this in the calculator that it looks the same as the formula. Hit enter and I get 22.608, which rounds to 22. L equals 22.61 is going to be my arc length. Now to find the area of the shaded arc, sector, whatever you want to refer to it, the shaded area there, the area of that sector is going to be, same formula, almost. I don't really expect you to memorize this one, so you can always flip to the top and get it, but it's pretty similar, right? Pi times radius squared times the angle, but this time we divide by 360 degrees. I don't need to find anything. I already found it in the last problem. So pi times 9 squared times 144 divided by 360. So when I go to my calculator, if I'm not using the fraction button, I can do 3.14 times 9 squared times 144. But before I hit divide, I'm going to hit enter to be safe, and then I'm going to divide by 360 degrees, and I ended up with 101.736, so 101.74 would be the area of that sector. All right? Okay, number 6, find the arc length of AB and the area. So this is exactly the same, except it doesn't give me the angle right off the bat. It gives me this angle. It gives me the degree measurement of this arc, but I don't want that arc. I want this arc. Nice thing is, all the way around the circle is 360 degrees. I want the rest of it right here. So I'm going to take 360. I'm going to minus 225 to figure out my arc length in degrees. So 360 minus 225 is 135, which means my angle is also 135. Easy, easy. So arc length L equals pi times radius 13 times angle 135 divided by 180. I don't want to drag this video out. Plug it in your calculator, get the answer. Area of that sector, that shaded area, is almost the same formula. Pi times radius squared, so 13 squared times 135 degrees divided by 360. Plug those in the calculator. Whatever you get is hopefully correct. Okay, number 7. Find the length of AB. So AB is this red section right here. What do I know? I know that when this and this chord cross each other, there's a relationship between the sides, and it tells me that this piece times this piece is equal to this piece times this piece. So I'm going to write that down algebraically. I'm going to use colors right here. I've got a red line, a blue line, a purple line, and let's go green. Okay, so the red times the green. So the AB times the green line, 6, is equal to the blue line, 5, multiplied by the purple line, 4. So AB multiplied by 6 equals 20. Railroad track tells me to divide by 6 on both sides. So now AB is equal to 20 divided by 6 is going to be what? 3.666, repeating forever, something like that. Yeah, that sounds right. 3.6. Oh, that's all it wanted for this one. So there's my answer. Whoa, circle. There we go. 3.66 is the length of that little AB piece. Okay, number 8, a little bit more of a problem-solving problem, right? It has lots of different things that cross. It's asking me to find AB and then BE. So I have AB is part of this line, so I'm going to use that line. And I don't want to use HE because I don't know, I only know 20, I don't know this part. So I want to use this line because I'm looking for this piece, and I want to use this line. These two chords are the ones I'm going to use. So if I color coordinate a little bit, this red part multiplied by this purple part should equal this green piece multiplied by this blue piece. So let's write that out algebraically. The red part, 4, multiplied by the purple part. Well, the purple part is two pieces put together, and one of them I don't know. I don't know this piece in the middle. So let's call that AB. And if I add that to 18, then I get the purple part. Okay, so the red line plus or times the purple line. So here's my red line, and here is, oh, I don't have a purple highlighter, shame. Here's my purple line, right? When I multiply those together, I'm going to end up with the green line, 10, multiplied by the blue line, 12. So a little bit of algebra, distribute. So 4ABs plus 72 equals 120. Railroad track, let's minus 72 first. So 4ABs is equal to what? 28, 48. Divide by 4, AB is equal to 12. Okay, thank goodness it was a nice number. So this piece right here is 12. All right, now it wants me to find BE. Well, BE is this piece right here. So I want to use that red piece and this purple piece. And now that I know what AB is, I can use this green piece right here and this blue piece to solve for the missing part. So let's go purple times red. So 20 multiplied by red. I don't know what that is. That's BE, right? 20 multiplied by BE is equal to, the blue is 18, the green is 4 plus 12 more, so the green is 16. So I get 20 BE is equal to 18 times 16 is going to be what? 270, 288. We better double check. 18 times 16, 288. All right, we're good. So 20B equals 288. Divide by 20. Divide by 20. BE is going to equal 288 divided by 20, assuming I did algebra correct. 288 divided by 20 equals 14.4. So BE, this right here is 14.4. It's not quite a perfect number, but I can live with 14.4 there. It's a decent decimal, if nothing else. So, time's yours. Do the problems on the back. I love the tables on 1 and 2. It gives you parts of the circle, and it wants you to find the other parts of the circle. Great question. They don't have pictures to go with them, but you guys all say you hate the pictures anyway. And then the last ones kind of look a little bit more like the pictures you saw on 5 and 6 and 7 and 8. The first ones are more like 1, 2, 3, and 4. So good luck.